Yo, 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 welcome to a new video. Today we are going to find some more points on temperature entropy diagram using the property relationships fundamental principle. So I'm going to start with the temperature entropy diagram. And I'm going to go ahead and draw a vapor dome, temperature, entropy, and let's see here. I'm going to put two lines of constant pressure. And to start with, I want you to find this point. So I will pick pressure. First of all, let's use water. And I'm going to have a pressure of 1,000 psi. And I would like you to find, let's call that point 1. At point 1, I would like you to find the temperature, the entropy, and the enthalpy. Press pause and find those three values. So I'm hoping that you went to table A3E, page 868, came down until your pressure was 1,000 psi. And right next to that, we can get the temperature, 544.75. And right next to that, we have, let's see, come all the way over here and get the enthalpy. And I'm hoping that you realize that it's not a saturated liquid, but rather it is a saturated vapor. So 1192.4 and 1.3903. So I'm going to go ahead and write those down. Temperature was 544.75 Fahrenheit. Entropy 1.3903 BTUs per pound mass degree Rankine. And enthalpy 1192.4 BTUs per pound mass. And let's go ahead and subscript each of these with a 1 because this is point 1. So the pressure at 1 is 1,000, temperature at 1 is 544.75, entropy at 1, enthalpy at 1. Next thing that we need to do is let's drop straight down and find point 2. And let's let the pressure here be 2 psi. So at 2 psi, I want you to find the temperature, the entropy, and the enthalpy. Go ahead and press pause. All right. Well, I hope that the easiest thing for you to find was the temperature, and you flipped back on, still on table A3E, went to a pressure of 2 and a temperature of 126.04. And then I hope the next easiest thing for you to find was the entropy, because the entropy is the same. Point 1 and point 2 all have the same entropy. So 1.3903. So Fahrenheit BTUs per pound mass. Now enthalpy 2 is a little bit harder. It's not a saturated liquid. It's not a saturated vapor. It's somewhere in between. And the question is, what percentage of the way? Well, the enthalpy is the same percentage of the way as the entropy. So I'm going to propose that we call that percentage of the way quality. Not a big supposition because we've already talked about this. And I'm going to say that the entropy, or the quality, is this distance over that distance. It's what percentage of the way am I from saturated liquid to saturated vapor. Well, my next proposal is that that's S2 minus SF. That would be the top distance, S2 minus SF. And then the bottom distance is SG minus SF. And all of these are readily available in the table. 1.3903 from above minus, from the table, entropy sub F is 0.175 minus SG minus SF, and those are both in the table, but so is SFG, which is that subtraction already done for us. So 1.7448. If you do the math, and I do need to do the math, .3903 minus 0.175 divided by 1.7448 equals 0.697, so 69.7%. 69.7%. So we now know how far point 2 is from point F to point G. We know the quality. We know what percent of the wet vapor is vapor. Well, I would then propose to you that if this equation is true for S, it's also true for H. So X2 equals H2 minus HF over HG minus HF, which we know in our table is HFG. And from the table, I can get HF, I can get HFG, and I can get X2. Alrighty, I know X2. The only unknown is H2. And real quickly with my calculator, I'm going to take 69.7% times HFG, and HFG is 1022.1. I'm cross multiplying, plus HF, which is 94.02. So I'm bringing the HF to the other side of the equation, and I get H2 equals 805.9 BTUs per pound mass. Give you something to ponder. Would you find for point 3, temperature 3, pressure 3, entropy 3, enthalpy 3, and quality 3? Go ahead and press pause and find all of those. All right, well, I'm hoping that you realize that point 3 is the F point, and the temperature is still 126.04. The pressure is still 2 psia. The entropy is SF, which we know is 0.175 BTUs or pound mass Rankine. Enthalpy 3 is HF, which is 94.02. And X3 is 0. 0%. We're 0% of the way from saturated liquid to saturated vapor. Before we go, I want you to take a look at this and come up with any questions that you might have about my drawing or about my work in finding point 1, point 2, and point 3. And just a little trivia before you leave. When you collect all of the properties at a point, that is called a state. So you've heard the term steady state. Steady state is when the state remains fixed over time, meaning that right now everything at point 3 has these numbers, and again right now, and 1 hour from now, and 1 day from now if we are in steady state. All right. Merry Christmas and a Happy New Year.